Hello again. Welcome back to the WTF is Cloud Native virtual conference. This is the technical track. Before I introduce the next speaker, just very small housekeeping stuff. Like I wanted to let you know once again, we have a code of conduct here. It basically says that the event we are really dedicated to providing harassment-free experience for everyone. You can find the code of conduct in the conference website. And now let's introduce our next speaker. So we will hear a talk by Holly Cummins, who leads the developer discipline in IBM Garage. The talk title is Why You Can't Buy Cloud Native. So I'm really excited to hear why is that tools won't help us actually to get cloud native. So yeah, over to Holly then.
Thank you. I want to set a little bit of expectations before I start as well, because I know this is the tech track, but my talk is a little bit of an anti-tech talk because, well, we all love technology, but I think, there's limits to what technology can do. And in particular, when we're thinking about cloud native, I'm quite convinced that you cannot buy cloud native. And that's a shame because thinking about shopping, we all love shopping, right? Whether it's, gadgets or whatever we're shopping for, shopping something, it makes us feel good. We can spend money and then we can solve our problems. But when it comes to cloud native, I think maybe we have a little bit too much hope for what buying is going to achieve. And when we talk about cloud native now, a lot of our conversation about cloud native is really focused on the technology and on the tools and on the gadgets. So I love Sam Newman a while ago said that he's finding increasingly when he goes out and talks to people who want to be cloud native, their starting point is, well, if I just get Kubernetes, I'm cloud native. And if I don't have Kubernetes, it doesn't matter how agile my releases are and how fast I'm moving, I'm not cloud native. That makes Sam sad. It makes me sad as well. And the starting problem when we go out to the shop and we try and buy cloud native, we've got our little CTO shopping list and it says cloud native. But what are we even actually trying to buy? We can probably, if we've been paying attention, we can narrow down on, okay, well, I need to be in this section of the shop. This is the right aisle. But in that aisle, there's a lot of stuff. So I mentioned already, a lot of us, we just go out and we try and install Kubernetes. And then, right, I've got Kubernetes, I'm cloud native. There's a really strong association now between cloud native and microservices. And there's this idea that, you have to do microservices. There's an older meaning of cloud native, which is born on the cloud. So these are systems that were, instead of being migrated to the cloud, were designed for the cloud. And so they avoided a lot of problems that we saw if we just tried to take something that didn't work on the cloud and make it behave well on the cloud. I think there's a lot of similarity as well between the ideas of DevOps and the ideas of cloud native in terms of an emphasis on automation, in terms of an emphasis on continuous delivery and getting that speed. But of course, when we talk about DevOps is another word that means so many different things that now, in order to make it clear that when we say DevOps, we mean automation and continuous delivery and working together rather than just the build team. So then we have to call it cloud native instead. There's another sort of, I don't see this very often at all anymore. I think maybe, I don't know if it's because we've gotten bored of it or we've all absorbed the ideas, but a lot of the ideas of cloud native historically that born on the cloud, that behaves well on the cloud, are really similar to the ideas of the 12-factor app. So things like, let's put our logging out as a stream, and then let's have it aggregated, those things that we now kind of take for granted with cloud native. And another meaning that I see, which I really like, is I think sometimes we get so used to talking about cloud native, and everything is cloud native, and we all want to be cloud native. We forget we are allowed to say just cloud. You don't have to put native on the end. Sometimes we're not actually talking about cloud native. Sometimes we are really just talking about cloud. And I think, again, sometimes when we talk about cloud native, all we're really trying to say is that this app was developed in 2021, and we used what we know about developing software in 2021 to organize our teams, to organize our tech stack. And it's just modern and nice rather than horrible and icky and legacy. There's a very technical meaning of cloud native as well, which is idempotent. I don't think we see this one very often, because whenever you say idempotent, you sort of go, item what? But what we really mean by idempotent, and this is a super important characteristic of cloud native applications, it's that if you give it the same request repeatedly, the same thing will happen each time. So it's rerunnable. We don't have a whole bunch of state buried in our application. And that's going to be really important in a cloud native context, because things are going to appear and disappear. And there's another meaning, which I feel really uncomfortable with, but I am seeing increasingly often as well, which is we talk about migrating something to be cloud native. And to my mind, you can migrate something, or you can be native, but you can't do both at the same time. So sometimes we talk about migrating our legacy apps to be cloud native, and really we mean that they're actually pretty much the same application, but we're hosting it on the cloud, which goes back to that definition of, did we mean cloud native, or did we just mean cloud? So that's a lot of different definitions of cloud native before I've even started talking about what we may or may not be able to buy. But I'd love to know, sort of presenting into the void, I'd love to know what you all think. So we've got a Slido poll. So you can either scan that QR code, or you can go to that URL if you're really good at typing from the screen, or you can just go to sly.do and then enter 684983. So if I start the poll, hopefully what you all should see is, if you go there, I'd love to hear your definition of cloud native, because after all, this is WTF is cloud native. And I think, I don't think there's a right one. And so I know last time I tried to do Slido at a WTF, it took quite a long time for the responses to come in, and I sort of was sat there going dum-de-dum-de-dum while we waited for the responses to come in. So I'll make idle small talk while we wait for answers, and then if it gets too long without answers, I'll conclude I really am just talking to the void and go back to the slides. So nothing yet. Nothing yet. Hooray! Yay! Yeah. So we've got a few coming in. We've got it's containers and microservices, and for a moment I was panicking that I didn't know what Orcas was, and I was afraid it was a technology I'd missed out on. But I think that's orchestration, and it just fell short of the word limit, the character limit. Oh, cool. Yeah. So we've got migratable. Yeah, I think that's a really nice one. The idea that you're not pinned to that particular bit of infrastructure. And that, you've got your infrastructure as code to allow you to really easily shift from one place to another. That's super important. And particularly, I think when we talk about Kubernetes native, we mean that sort of infrastructure as code. Oh, cool, lots coming in. So it's a change in tech and culture, processes. It's the ability to experiment and fail fast. We've got transformation and paradigm, and mostly all about people. Oh, good. So I think, we're all definitely on the same the same track here. So that's good. And we've got, yeah, a set of behaviors. Yeah, definitely. I really like saying that, and I did a talk called Cloud Native is about culture, not containers. And I know that talk had some success because for a while, if you went to Google and you typed in Cloud Native is about, it would come up with culture, not containers. So I'm probably preaching to the converted a little bit here because I think, yeah, we're all, very focused on that, those behaviors and the ability to deploy quickly. Yeah, absolutely. Okay, cool. So that's a good level set. So I want to go back to some of the things that I was talking about as potential interpretations of cloud native. And one of them is microservices. Microservices are really strongly associated with cloud native. They've softened it a bit, but for a while when you went to the CNCF site, it basically just said microservices. And I think probably a lot of us have had the experience recently that if you talk about something greenfield and you try and decide what the architecture is going to be, you go to the architecture shop and you sort of look around and the only option is microservices. And, doesn't matter what your requirements are, the answer is microservices. And then, if you really insist, they'll take you to the back of the shop past all the shiny displays of microservices. And there's, one sort of dusty monolith that back there that they say that nobody's asked for 5 years. So, microservices are sort of this new orthodoxy. But I think that pendulum is shifting back, which I think is a positive thing. So next poll is for those of you who've had the luxury of starting a new project rather than just continuing on with what you've been working on, what way did you go? Did you go with monolith or did you go with microservices? So let's have a look and see what people think. So cool. So have you started a new monolith recently? And we've got the options of course not. Microservices are the new orthodoxy. Yeah, no, and yes, but we switched to microservices as we scaled up. I probably should have added another option as well, which is we planned to switch to microservices, but then we never got round to it, or we haven't got round to it yet. Okay, so we've got a bit of a mix. Yep. Oh, shifting. Yep. So we've got some people have done that monolith first approach. Some people have done monolith first, but then switched to microservices. And then we've got a few people who are saying, no, I wouldn't start with a monolith. Oh, yep. So now, yeah, we're getting a bit more of starting with monolith and then switching to microservices, which I think is probably a really sensible approach because you're going to understand your domain boundaries better and you're going to save a whole bunch of work at the beginning. Okay, so back to the slides. So why are we all doing microservices? Is it because we have a really solid understanding of the architectural trade-offs? Sometimes, but honestly, I think sometimes these things are just like anything else. We get trends in our architecture, and the reason we go for microservices is partly just because we care what others think about us, and we want to say here's my microservices system, not have to say here's my monolith and then have people go, you what, haven't you been paying attention? And you may think, oh no, this is too cynical, surely nobody would actually do it that way, but there's evidence that we do. So the Red Hat did a survey on the drivers for container-based development, and one of the main ones was career progression. So that career progression is just a nice way of saying CV-driven development. So we want to get up to date with containers because everybody else is doing it, and we want to be in with the architecturally cool crowd. And of course, it's not, I'm being a little bit unfair because it's not just about vanity. It's not just about keeping up with the Joneses. This is exciting stuff. When you look at the CNCF landscape, there's so much there. It's, there's all of these technologies. And then this comes back to shopping a little bit as well, because, it's this landscape to explore, but it's also a catalog, and we kind of can go, oh, I'll have one of those and one of those, and oh, look how shiny that one is. And, we get to play with tech, which is what we all love doing. But I think we do have to step back and say, wait a minute, what problem am I trying to solve? And, I think sometimes the starting point is, I think I need more containers, but my problem is that there isn't enough containers. That's not a real problem. That's not a problem, that our company will thank us for solving. And when we go with microservices, when we redo our company's tech stack in order to plump our CV, we do hit problems. So, if we start with microservices, then it's a can of worms. Oh, no, okay, no. It's not a can of worms. It's just cloud native spaghetti. I'm not sure if that's actually better or worse, because, we're sort of aiming for microservices, but then what we actually end up with is, inside we've got all this coupling, and, it's just cloud native spaghetti, which is another way of saying it's a distributed monolith. And a lot of us are seeing this, we spread out over different repos, but we still basically have a monolith. And a distributed monolith is basically the worst of both worlds, because we lose a lot of the things that we get with a normal monolith. So our IDE doesn't help us out by checking for type safety and methods. And if we call another method, it may or may not even exist. And with microservices, I think we have to remember that microservices, the goal of cloud native shouldn't be microservices. They're just a means, and they're only one means, really. They're not the only means. And I think a lot of us just, sort of maybe, again, started focusing on the wrong problem. So when we look at our microservices architecture, there's this idea that the cloud nativeness is in the connections. The cloud nativeness is in the HTTP connections, but that's not what makes cloud native cloud native. That's just a side effect of the fact that we opted for a distributed system. And yeah, so spoiler, no, that's really not where the cloud nativeness lives. And there's a lot of really good reasons not to do microservices. So if you have a small team, not worth it. If you're never planning to release these things independently, not worth it. There's a lot of talk these days about service meshes, and a lot of times the first starting point is, oh, no, service mesh. Oh, no, much too complicated. I don't want a service mesh. But then what ends up happening is we still have those requirements for how can I do discoverability? How can I do security? And so we end up just writing a little utility or two, or another little utility, and then extracting some common code because every microservice was solving the same problem. And then actually we still have a service mesh. It's just we wrote it ourselves, and that's not an improvement. And then finally as well, sometimes the domain model just doesn't split nicely. It's just too entangled. There is only one domain model, so we should only have one service. And I think when we think about microservices, we sometimes forget the distributed computing fallacies, So I'm hoping, I had terrible network problems yesterday, so I'm hoping my network is reliable today. But, then there's a whole bunch of other ones. And I want to add a final one to this list, which is we sort of assume that if we're distributed, well, we might have to deal with a bit of unreliable network, but we'll be decoupled. Well, no, it doesn't work that way. I've seen a lot of projects, and one of the first microservice projects I did, I was called in, and the reason they called me in was because every time they changed one microservice, another one broke, which is of course the opposite of decoupled. It's the opposite of what you're supposed to be getting. But just because you're distributed doesn't mean you're decoupled. Okay, so if you can't make yourself decoupled just by putting lots of HTTP communication in your application, how do you even know if you're decoupled? I heard a really good heuristic lately, which I like. So you're decoupled if you can deploy independently. And you can tell if you can deploy independently really quickly by looking at the versions of all of your microservices. If you look at the whole estate and everything's at the same version, then you don't even need to talk to a human being. You know that these things aren't independently deployable. Whereas if you see a much more heterogeneous set of versions, it's not a guarantee, but it's a pretty good health sign that we are actually getting that cloud native dream and deploying independently. And often what we see in organizations is not only are they not independently deployable, everybody's so scared of deploying independently that we instrument the build pipeline to make sure that there's no chance that one of those suckers is going to escape without all the others coming with it. Which again, if we're doing this, we have to ask, what is microservices giving us? But of course, sometimes it's worse than that. Sometimes not only is there a single pipeline enforcing everything gets deployed at the same time, things don't even get deployed at all. So I've got the last poll, although my phone has just locked, so it'll take me a moment to bring this one up. Okay, so the last poll, which is, how often do you deploy? And by deploy, I mean get something out to prod, not just to staging. So the options are multiple times a day, daily, weekly, every other week, once a quarter. And then, deploying. Oh, no, that sounds quite risky. We try and avoid doing that. We just write the software and then leave it where it is. Cool. So we've got multiple times a day. Excellent. Oh, yep, it varies a lot. Yeah, weekly. Yep. Oh, yep. More votes for weekly. Yep. Oh, a bit of a mix. Yep. Some quarterlies creeping in there. Bi-weekly. Nobody doing once a day, interestingly. Yeah. Yeah. The majority seems to be sort of settling on weekly. And I think that's, that's honestly pretty healthy. And if you're doing it weekly, you should feel pretty good about yourself. And one of the things I think that, it enables that weekly deployment is keeping a bit of a distinction between releasing and deploying. So deploying is taking the artifacts and putting them onto production, but releasing is having somebody use them. And of course, that's where the perceived risk is. And there's a lot of things that we can do to reduce that. So we can deploy it, but we don't even have to wire it into anything at all. We can use feature flags in order to make sure that we can turn it on and off independently of that deploy lifecycle. We can use things like A/B testing and canary deploys to keep it safe. But what we often see is that none of these techniques are used. So companies will say, we have a CI/CD, but that's not the same as DevOps, which is also something that you can't buy DevOps, and you definitely can't buy a DevOps, although people try. And CI/CD, it's not something you buy, it's something that you do. And what we see is often the C gets kind of lost, and we sort of end up with the, we're talking about CI/CD, but we're only releasing every 6 months. So that's not continuous deployment. So I sometimes think, have we even forgotten what continuous means? And if we don't have that continuousness, if we don't have those good habits with releases, that means all of the microservices in the world won't do us any good, because we have these external structures that prevent us getting that independent deployability, and prevent us getting deployability at all. So we end up, with these sort of things where releasing is something that, we only do on really special occasions, and we can't release the microservice with the release board, and all the other microservices have to go at the same time. And then there's the manual QA cycle, of course, and then there's a release checklist and an incantation and a death march and a spreadsheet and sacrificing a goat. And then, only if the moon is in the right phase. And, just makes me sad. And often the reason we're so reluctant to release is because we don't have confidence in the quality. And the reason that happens is because we haven't automated the tests. And what that means is we have no idea if it actually works. So of course we're not going to release it. But really, if you're going to be spaghetti, at least be tested spaghetti. There's another thing that I think, does stop us releasing. And that's sometimes these systems just end up being, with the best will in the world, really hard to change. And that's because even if we have microservices at one layer, there's a whole bunch of other layers. So we kind of, in any kind of non-small organization, you end up with this enterprise hairball. So we've got, our layer, which is the business layer, and we divide that beautifully into microservices. Then there's the front end. And then there's the database. That's a lot harder to divide. And then if we're a big organization, then there's the integration layer as well. And they're sort of getting requirements from everywhere and not getting enough resources. So then we realize, even though we're making changes on the microservices, we have to divide up the front end layer to get anywhere. And we have to divide up the database, and really we have to divide up the integration layer as well. And there's patterns for this. So we need to be thinking about that independently deployability all the way through. And if we're going to do that as well, we need to be thinking about ops in a different way. So we need to be bringing in things like SRE, and we need to be bringing in a new way of thinking about risk. It's not more risk. It's just realizing that the best way to de-risk isn't to add more and more paperwork. It's to automate, and it's to get things that we care about as code. Because in the cloud, in any kind of cloud native environment, that old style governance is just not going to work. It's not going to make it safer, and it's going to make it a lot more expensive. Years ago, we sold some provisioning software to a client, and it was supposed to do 10-minute provisions. This was a while ago. And we got a complaint because it was taking 3 months to provision anything using this tool. And when we investigated, we found that there was an 84-step pre-approval process before anything could be provisioned. So of course it took a long time. There is one thing you can buy, though, with Cloud Native, and that's cloud. You can buy a lot of cloud, but of course you may not actually want all of the cloud that you bought. Often we're just burning money and it's not actually valuable. When I was learning Kubernetes, I created a cluster, as one does, and then I forgot it for 2 months because I had too much work in progress, and it was £1,000 a month. So that was just money burnt. And you can burn a lot of money really, really quickly with cloud services, especially if you have the automation that does the wrong thing. And so what a lot of organizations, the habit that they have for the cloud is just wading through their cloud bills, trying to figure out what all this stuff is. So I think we can shift this left. Spotify are doing really interesting things to make that cost information an engineering concern. And at a higher level, we're seeing this, sort of as FinOps. So to finish, I think when we talk about what cloud native is and what we need to be thinking of, there's this sort of hierarchy of how tangible things are. The products, they're really tangible, but they're not necessarily going to make you cloud native. We also need the architecture. We also need the operations. And then we also need those sort of business drivers. And those last two bits are the sort of the woolly bits that I think you'd maybe describe as culture. And so you need the culture as well as the products. And with that, I'm looking forward to questions and chat on the platform, and please catch me on Twitter as well. Thank you very much.
Thank you, Holly. That was really, really great. Thank you for that great talk. I think we've all learned a lot. We have one question from the audience. So the question asked by Tom is, so is REST an anti-pattern in cloud native? like thinking of events queues and RSocket as better alternatives. What's your opinion on that?
I mean, like everything, it depends on your use case. You know, the events and queues, they have really good scalability behavior. They can be harder to get your head around. So I wouldn't necessarily do everything, maybe sort of consider events and then consider other changes, or just be a bit incremental with it, because otherwise you can just end up again with a system that's really hard to reason about because it's got too many unfamiliar paradigms in it.
That's great. Thank you. Yeah, with that, I think, yeah, we would go for a short break, and then the next talk starts in 15 minutes. So thank you once more, Holly, for that great talk. And if anyone got more questions, please reach out to Holly to ask those. Thank you.